Hi children, welcome. In this class, we are discussing yet another important organic chemistry chapter, 12th standard topic, amines. The last recognized organic chapter from 12th standard topic. Okay, a small chapter. Let's go through the important aspects in the chapter, amines. All of you know what is amines. Amines are ammonia derivatives. Amines are ammonia derivatives, right? Ammonia derivatives of aliphatic and aromatic compounds, right? So this is ammonia. This is ammonia. All of you know sp3 hybridization and pyramidal geometry with a lone pair of electron AB3 E-type molecule. AB3 E-type molecule. When one or more of the hydrogen atom replaced by alkyl or aryl group, we get amines, aromatic and aliphatic amines. One of the hydrogen atom replaced by alkyl group, you get RNH2 like this. This is called RNH2 called primary amine. Primary amine. The simplest primary amine, all of you know, CH3NH2, methanamine, methylamine, so called methanamine, ethanamine, propanamine, butanamine, goes like that, right? Now, when two hydrogen atom replaced by alkyl group, either same alkyl group or it can be different alkyl group. It can be RRNH, which can be written as R2NH, or it can be RR dash. It can be RR dash NH, that is called a secondary amine. All of you know. So primary amine recognized by NH2 group, secondary amine recognized by NH group. When all the three hydrogen atom replaced by alkyl group, you get a tertiary amine which comes out like this, R, 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 like this, and that will be tertiary amine, R3N, tertiary amine. Or it can be R, R dash, R double dash, can be R, R dash, R double dash N, that will be tertiary amine. So primary amine, secondary amine, tertiary amine. Primary amine obtained by replacing one of the hydrogen atom of ammonia. Secondary amine obtained by replacing two hydrogen atom. Tertiary amine obtained by replacing all the three hydrogen atom. And if the lone pair also getting involved in the bonding, you get a quaternary ammonium salt, R4N plus X minus. That will be a quaternary ammonium salt coming like this. All four bondage linked with the alkyl group like this. You get a NR4N plus. That is a quaternary ammonium salt. So this is ammonia. This is primary amine RNH2. This is secondary amine R2NH, and this is tertiary amine, right? So they are obtained by replacing one or more hydrogen atom of ammonia. When one hydrogen atom replaced, you get primary amine. Two hydrogen atom, you get secondary amine. Three hydrogen atom, you get tertiary amine, right? And simplest aromatic amine known to all, simplest aromatic amine, the so-called aminobenzene or aniline, the very popular aniline, aminobenzene, benzenamine, aniline, right? This is the introduction regarding the amines. As ammonia, all of you know, it acts as a Lewis base. All amines act as bases. All amines act as bases. In fact, aliphatic amines are more basic than ammonia, while aromatic amines are less basic than ammonia, right? If you go through the NCERT, in the initial paragraph itself, you can find many molecules which are explained as an introduction part. The two biologically active compounds, adrenaline, known to all, fight and flight hormone, adrenaline, ephedrine, very popular one, both are containing secondary amino group. They contain secondary amino group used to increase blood pressure, related to blood pressure. Novocaine, synthetic amino acid used as anesthetic, Novocaine, used in dentistry. Benadryl, a well-known antihistaminic drug, anti-allergic drug, Benadryl. So certain names which are quoted in the introduction paragraph itself, it will be advisable you go through you just try to familiarize those molecules, particularly adrenaline, ephedrine, etc. You can very well see this is adrenaline which contains secondary amino group. You see that NH group, secondary amino group. This is adrenaline, right? Adrenaline, noradrenaline conversion, how it influences the blood pressure related to, you know that. This is ephedrine. Once again, it is a secondary amino group, NH. How to identify primary, secondary, tertiary? NH2 primary, called amino group. NH2 primary, called amino group. This group is called amino group. NH2 group, amino group. While NH group will be called imino group. Imino group. They are functional group isomerism. Amino group, imino group, simply tertiary nitrogen, like that. So this contains secondary amino group, this contains tertiary secondary amino group, right? While this is the so-called Novocaine, which contains tertiary amino group. This is Novocaine, and this is Benadryl, used as antihistaminic drug, that is also containing tertiary amino group. So in order to give a picture regarding primary, secondary, tertiary amino groups, the textbook introduced with a few very popular molecules, right? Like adrenaline, which contains secondary amino group, like ephedrine. There are many molecules, right? And there is Novocaine, anesthetic chemical, and this is Benadryl, right? Antihistaminic medicine commented there in the. So just to go through all these part, including as an example given in the textbook, it must be important to get familiarized with that molecule. I am not talking like you just by heart the structure, that may not be relevant, but familiarizing that molecule, because there is every possibility that those molecules are taken up for a discussion of something related another area. Okay, so that's about classification of amines. I mean, particularly how amines can be understood, like NH2, they are primary amine, NH will be a secondary amine, N will be a tertiary amine. This is the structural identity of amines. It will go for AB3 E-type system, 3 bond pairs and 1 lone pair, right? Already commented primary, secondary, tertiary. And regarding the naming, common name will be alkyl amine, while IUPAC name will be alkanamine. Have a look at this. Ethyl amine, ethanamine. Normal propylamine, N-propylamine, propan 1 amine. Sir, should we give propan 1 amine? Yes, propan 1 all, propan 1 amine, because this is isopropylamine, that is propan 2 amine. What is the nature of the amine? Primary, secondary, tertiary. What character of amine it is? Normal propylamine, isopropylamine. They are primary, secondary, tertiary. Don't make a mess up. Both are primary. This is also primary. This is also primary. Identifying primary, secondary, tertiary. Look at that NH2 primary, NH secondary, N tertiary. This is ethyl methyl amine. Ethyl methyl amine, which will be called N-methyl ethanamine. What is N-methyl? N for nitrogen. N-methyl ethanamine. Right? Trimethylamine. Trimethylamine. That will be N-N dimethylmethanamine. N-N dimethylmethanamine. Over nitrogen, you have a methyl group. So, N-methyl, N-methyl, N-N dimethylmethanamine. Right? So, in primary amine, you will not find this N. In secondary amine, there will be one N, and in tertiary amine, there will be two N. That in fact is a very simple way to identify primary, secondary, tertiary with the IUPAC nomenclature. In IUPAC naming, if you don't find any capital N, it is primary. If it is one N, it is secondary. If it is N, it is tertiary. That is another way to identify. Okay. Yes. Proceeding further on that table, it is N-N diethylbutanamine. N-N diethylbutan, one amine. You see that 1, 2, 3, 4. N-N diethyl. N-N diethylbutan, one amine. Right? Next, allyl amine. This is allyl amine. 1, 2, 3. It is prop 2-in-1 amine. Prop 2-in-1 amine, allyl amine, right? Hexamethylene diamine, hexamethylene diamine, that will be hexane 1,6-diamine, very popular in polymeric industry and all. Hexamethylene diamine, used in the preparation of nylon 6,6. Hexamethylene diamine, hexane 1,6-diamine. Should we give 1,6? Definitely you should. Hexane 1,6-diamine. This is very popular. Aniline or benzenamine. Aniline or benzenamine. The name aniline itself is accepted by IUPAC. That much popular it is. Okay. Then there is toluene. Toluene. What is toluene? Methyl aniline called toluene. Methyl aniline called toluene. So it is 2-methyl aniline. 1, 2. 2-methyl aniline. Even you may call it as 2-aminotoluene. You may call it as 2-aminotoluene. No problem. So it is 2-methyl aniline. 2-methyl aniline. 1, 2, 2-methyl aniline. Here it is 4-bromobenzenamine. 4-bromobenzenamine or 4-bromoaniline. And what about this? What about this? An amino group, aniline, which is secondary in nature. Secondary or in fact tertiary. This is a tertiary aniline. The name will be N-N dimethylamine. N-N dimethyl benzenamine or aniline, a tertiary amine, like that. Is that clear? Is that clear? That's about the nomenclature part. That's about the introduction about amines. Primary, secondary, tertiary, aromatic, aliphatic. See, asking for primary, secondary or tertiary. This is very well understood. Primary, this will be tertiary, and this will be NH2 primary, and this will be NH secondary, like that. This is a very popular question. C4H11N. How many isomers are possible? Try to do that. How many primary are possible? How many secondary are possible? How many tertiary are possible? And what will be their IUPAC name, right? Now on to preparation of amines. Preparation of amines. First one, reduction of nitro compounds. Reduction of nitro compounds. Preparation of amines. First one, nitro compounds reduced to amine by passing hydrogen gas in presence of finely divided nickel, platinum or palladium. Or it can be metals in acid medium. Metals in acid medium. So it can be number one like this, hydrogen with a catalytic hydrogenation reaction, or number two it may be chemical reaction like this, tin with HCl, iron with HCl, where we can find the nitro group is converted to amino group. NO2 reduced to NH2 group. So it can be either catalytic reduction or tin with HCl, iron with HCl, metals with HCl, like that. It is recommended here the reaction with iron, scrap and hydrochloric acid is preferred. This one is more preferred out of HNHCl, out of iron HCl, which is more preferred. More preferred is iron with HCl. Why iron with HCl more preferred? Because there you get FeCl2. So what? FeCl2 get hydrolyzed to release hydrochloric acid during the reaction. So what? Thus only a small amount of hydrochloric acid is required to initiate the reaction. You don't have to give a continuous supply of HCl. Only starting stock of HCl is enough, because with the reaction you get FeCl2 and FeCl2 hydrolyzed back to give HCl. So HCl is continuously produced and used up in the reaction. You don't have to give a continuous supply. That is an advantage, right? So that's about the preparation of aniline or amine from number one, nitro compounds. Nitro compounds reduced to amine either using catalytic reduction or using chemical reduction. Metals with the HCl. Iron with HCl get a special privilege. Okay. Number two, Hofmann's ammonolysis reaction. Number two, from alkyl halides, Hofmann's ammonolysis reaction. This is Hofmann's ammonolysis reaction. It is so called Hofmann's ammonolysis reaction from alkyl halides. Alkyl halides treated with ammonia. There will be SN reaction. There will be SN reaction. X is substituted by NH2. You get RNH2 releasing HCl. Okay. So you get primary amine. Okay. Imagine this is taken in excess. Suppose this is taken in excess. There will be continuous reaction. Again, Rx can react. This X replaced by that, it's giving a nucleophilic attack. Nitrogen make a nucleophilic attack on R. You get R2NH, one more HX out. Now you get a secondary amine. It may give further reaction with Rx. You will get a tertiary amine, R3N, tertiary amine. And there is a lone pair of electron. It can further react with Rx and you get R4N plus X minus, quaternary ammonium salt. So Rx when treated with ammonia, you can find SN reaction taking place. First you will get a primary amine. Subsequently, it may continuously react with the alkyl halides. Further, if you take excess of alkyl halide, you get a primary amine first, then secondary amine, tertiary amine, and then you get a quaternary ammonium salt. Is it clear? Is it clear? It will continue like that. So this reaction is not usually preferred in the laboratory method, as you get a mixture of products. If alkyl halide is taken excess, you get the reaction proceed to last. If ammonia taken excess, Suppose this is the limited quantity and ammonia is taken excess quantity, you may get a preferable primary product. So if you want to get a more primary product, take ammonia excess. If you want to go to reaction, go to the last or proceeding further, you may take excess of alkyl halide, and this is called the Hofmann's ammonolysis reaction. Along with the Hofmann's ammonolysis, Hofmann's elimination type reactions are also discussed in the classes. So, if you remember, it is detail given in the notes, which of course is out of syllabus as far as board exam is concerned. But the importance of Hofmann's ammonolysis, Hofmann's exhaustive alkylation, Hofmann's elimination reaction, various conditions involving Hofmann's elimination reaction, all discussed in prime importance, and the detailed notes were given, which is in relevance to the competitive aspect or competitive requirement for the various other exams than board exams. You may please review those notes separately. Okay. So that's about Hofmann's ammonolysis reaction, preparation of amines from alkyl halides, and the order of reactivity of alkyl halides, as usual, it is alkyl iodide, which can be easily substituted, then bromide, then chloride, all of you know. And the other method is reduction of nitriles. Reduction of nitriles. How RCN reduced to get a primary amine. How RCN reduced to get a primary amine. You see, this is nitrile, which is reduced by catalytic reduction. Hydrogen with nickel. Hydrogen with nickel. Catalytic hydrogenation. Catalytic hydrogenation. Or it can be metals with alcohol, sodium amalgam with ethanol, sodium amalgam with ethanol, or it can be lithium aluminum hydride, lithium aluminum hydride. So CN can be reduced to amines. CN can be reduced to amine. This C will turn CH2 and this N will turn NH2. What actually happening is very simple to understand. RCN, the triple bond is gone. RCN, the triple bond is gone and is getting saturated. How saturated? Carbon valency is 4, so there will be 2 hydrogen like this. Nitrogen valency is 3, so there will be 2 hydrogen. So you get RCN turn, RCH2, NH2. The complete reduction of nitriles can be done either by using lithium aluminum hydride or catalytic reduction or sodium amalgam with ethanol. Sodium amalgam with ethanol. It is particularly known with a reaction name Mendius reduction. Mendius reduction. Alkyl nitriles reduced to primary amine using sodium amalgam and ethanol. The reaction called Mendius reduction. And it was also taught in the classes what happens if you take isocyanide. If you take isocyanide, what do you get? You get a primary amine and you get a primary amine. There you get a secondary amine with a terminal CH3 group. Or NHCH3, a secondary amine with a tertiary CH3 group. Also taught in the classes, right? Fine. Next is reduction of amides. Reduction of amides. So reduction of nitriles and now reduction of amides. Reduction of amides. This is amide, which is reduced by lithium aluminum hydride, where this oxygen will be thrown away and you get CO turn CH2. CO turn CH2. Right? So reduction of amide, CO group will turn CH2 group. By replacing oxygen, you get 2 hydrogen substituted as a result of reduction procedure. So reduction of nitro compounds, Hofmann's ammonolysis reaction, reduction of nitriles, Mendius reduction, and various other cases. and now reduction of amides, right? Next is the very famous Gabriel phthalimide synthesis. Gabriel phthalimide synthesis. Gabriel's phthalimide synthesis using phthalimide. Hope you remember, this is so called phthalimide. Gabriel's phthalimide synthesis. This is phthalimide. We have learned in the previous chapter about phthalimide. This is phthalimide, and phthalimide is treated with KOH. Phthalimide treated with KOH, and this is sufficiently acidic to neutralize, and you will get potassium phthalimide. You get available in the salt form. Potassium phthalimide. Phthalimide turn potassium phthalimide. Here you get N minus K plus, and thereby it improves the nucleophilic nature. Compared to this is a better nucleophile, and this is potassium phthalimide. Potassium phthalimide. And there comes the important part of the reaction. It is further interacting with the RX. It is interacting with the RX. All of you know it will be polarizing like this, minus and plus, and over this minus, this nucleophilic attack occurs. And of course, KCl is out, KX is out. You get alkyl phthalimide. You get this term, alkyl phthalimide. Potassium phthalimide turn alkyl phthalimide. This will turn R, and you get alkyl phthalimide, N-alkyl phthalimide. Okay. And now the last one is hydrolysis reaction. It is taken for hydrolysis reaction, where it is going to cleave like this. It will cleave like this. You know, N minus will get H plus. 2H plus will be abstracted by N minus, and this will turn acid. You get the remaining part as phthalic acid. You get the remaining part as phthalic acid. If it is alkaline medium, this will be in the form of salt, and here you get RNH2, the product we are looking for. You get aliphatic primary amine. You get aliphatic primary amine, and that is the relevance of Gabriel reaction. Gabriel reaction is meant for the preparation of aliphatic primary amine. Why not aromatic? Why not aromatic? If you want to get aromatic, here you must use chlorobenzene or halobenzene. If you use halobenzene here, you will get aromatic amine here, isn't it? And that is not practically possible. Why that is not practically possible? And they hardly give any nucleophilic reaction. You cannot break this bond easily. Aryl halides are extremely less reactive towards nucleophilic substitution reaction, isn't it? So that reaction is not possible. So Gabriel reaction is mainly meant for preparation of primary aliphatic amine, not aromatic, because it is ultimately it is a SN reaction. So look at the reaction once again. We have phthalimide. Starting with the phthalimide, treated with the KOH, you get potassium phthalimide, an effective nucleophilic species, and that interact with alkyl halide, you get alkyl phthalimide, and that alkyl phthalimide upon hydrolysis will cleave over this region. You get Rn turn RNH2 primary amine, and this you get phthalic acid. And if you are dealing with the alkaline solution, phthalic acid will be in the form of salt. That's all. That is Gabriel reaction. Clear, right? Fine. Good. And the last one, Hofmann's bromamide reaction. Hofmann's degradation reaction. Hofmann's degradation reaction. That is the last one. This is what Hofmann's degradation reaction. An amide treated with alkali NaOH and bromine. An amide is treated with NaOH and bromine. This is Hofmann's degradation reaction. Hofmann's degradation reaction. Or Hofmann's bromamide reaction. Since it is a descending reaction, it is also called a degradation reaction. What is the reaction? An amide treated with the bromine and alkali. You get primary amine, sodium carbonate, NaBrH2O. The prime importance is that this CO group is gone, and hence this is out as sodium carbonate, and look at the product obtained. Product obtained contain one carbon less. Hence it is a degradation reaction, descending reaction. The number of carbon atom decreases. Hence it is so called. Right? So what is the reaction? A primary amide treated with bromine and alkali. You get a primary amine with one carbon less. Imagine you are dealing with benzamide. Imagine you are dealing with the benzamide or any such amide. You can easily identify the product obtained. You can easily identify the product obtained. How to identify the product? Very simple, no? How to identify the product? Just eliminate CO group. Just eliminate CO group and attach NH2 group over here. You get your answer. So this will give you this CO out. That's a very simple way to understand product in Hofmann's degradation reaction. At the same time, you might have gone through the detailed aspects of the reaction also. You must know the story behind. You must know the mechanism behind. Even though it is not referred in the textbook, you must know. You must know because it is competitively important. What is the story behind the Hofmann's reaction? What is the mechanism involved in Hofmann's reaction? Please have a look at RCONH2 plus Br2 plus NaOH molecule number 1. Very simple to understand. You see Na plus and Br minus out as NaBr. Okay. Now OH minus and H plus out as H2O, and NH2 minus with Br plus, you will get a bromamide, RCONHBr. That is called a bromamide. So NaBr out, OH out, and NH2 minus with the Br plus, you get a bromamide. This will repeat once again. This will repeat. And you see the reaction getting repeated. This is repeating again with NaOH, OH minus and H plus out as H2O, Na plus and Br minus out as NaBr, and you get a very popular reactive intermediate involved in the reaction, it is RCN dot dot. You get the so-called nitrene. This is called nitrene, a very popular reactive intermediate formed in between the reaction. So RCONH2 Br2NaOH, you get bromamide. That again react with NaOH, you get OHH2O out, NaBr out, you get RCON dot dot. That is so called nitrene. Okay. Now there is an important twist in the story, is nothing but this alkyl group is going to migrate like this, which is referred in the text. In the text, when you go through, you can find there is a comment on migration of alkyl group from carbonyl center to nitrogen center. In fact, it is based on the mechanism involved, even though the mechanism is not dealt in the chapter. So this alkyl group is migrating to nitrogen, and the net result will be you get RNCO, that is alkyl isocyanate. Alkyl isocyanate, a very popular class of compound, historically also important. One of the biggest tragedy ever happened in India due to MIC, methyl isocyanate, methyl isocyanate, alkyl isocyanate. And now this is treated for hydrolysis. There are two NaOH involved. It is going to break here. Rn will turn RNH2. That is the product we are looking for, the primary amine. Primary amine with one carbon less. And this CO with 2 sodium, 2 oxygen will turn Na2CO3. Na2CO3. Now you can very well take an account according to the balanced equation. There is one amide, there is one amide, there is one bromine, there is one bromine, there is NaOH 1, 2, 4. There are 4 NaOH. You get to RNH2 one product. Yes, RNH2, one sodium carbonate, 2 NaBr, one here and one here, 2 NaBr, 2 H2O, 1 H2O, 1 H2O here. That gives the complete story and the script of Hofmann's degradation reaction, Hofmann's bromamide reaction. Is that perfect? Right? Yes. That's all regarding preparation of amines. Reduction of nitro compounds, Hofmann's ammonolysis reaction, reduction of cyanides, reduction of amides, Gabriel reaction, and Hofmann's bromamide reaction. Okay, fine. Next, a small talk on physical properties of amines. Physical properties of amines. You can have a talk on physical properties of amines. Lower aliphatic amines are gases. Lower aliphatic amines are gases with a fishy odor. 3 or more carbon atom liquid, still higher one will be solid. Aniline and other aryl amines, usually colorless. Aniline and other aryl amines, usually colorless, but get colored on storage due to atmospheric oxidation. See, these statements even, I would say, very, very important, because statement based questions, including for JEE exam and even for the numerical part of JEE exam, that's quite interesting. Not only for the section A, section B where there is 10 numerical part question, coming numericals is okay, quite acceptable. What about numerical question coming in such a way that some 5-6 statements are given, and they ask you how many of the statements are correct or incorrect, and thereby they try to make it numerical. See that? So statement part of questions are even important in the numerical aspects. I mean, in that segment they try to include like this. Each and every numerical, I mean every statement also is very, very important from the NCERT content. You must take effort to go through that vital points which can come as a question. Lower aliphatic amines are soluble in water because they can form hydrogen bond with the water molecules. As the size increases, hydrophobic alkyl part increases and the solubility get suppressed. Higher amines are essentially insoluble in water. Considering the electronegativity of nitrogen of amine and oxygen of alcohol, nitrogen 3, oxygen 3.5, asking, can you predict the pattern of solubility of amine and alcohol? Which is more soluble? Which is more soluble, amine or alcohol? No doubt. No doubt. Which is more soluble? Alcohols are more soluble. Why? Oxygen is more electronegative. So what? A greater electronegativity of oxygen causes greater extent of hydrogen bonding. And greater the extent of hydrogen bonding, greater the solubility in water. It's as simple as that. Fine. So butane 1 all, butane 1 amine, which is more soluble? No doubt, butane 1 all is more soluble. They are soluble in organic solvents also. Alcohols are more polar than amines. Alcohols are more polar than amines and make stronger intermolecular hydrogen bonding than amines. Who? Alcohols. Primary and secondary amines are engaged in intermolecular association. Primary and secondary amines are involved in intermolecular association and is more in primary amine. Intermolecular association more in primary amine than in secondary amine. While tertiary amine do not have intermolecular association because there is no hydrogen. There is no hydrogen. So if you take primary amine, it is RNH2. The association possibility number 1 over here, number 2 over here, and number 3 losing the lone pair over here. What about secondary amine? RNH. And there can be 1 over here and 1 over here if any supportable molecule comes. Otherwise, only here. And tertiary amine, there is absolutely no possibility as there is no hydrogen. Only this lone pair is present. So, greater extent of hydrogen bonding, no doubt, with the primary amine, then secondary amine, then tertiary amine. And of course, it plays a vital role in deciding the basic strength of amines. Okay, yes. So that's about the physical properties concerned. Here you can have a comparison of boiling point. Comparison of boiling point for amines. You see almost same molar mass. How comes the boiling point? This is primary amine, secondary amine, tertiary amine. This is primary, secondary, tertiary. You see the boiling point, primary amine greater than secondary amine greater than tertiary amine. So this is primary, this is secondary, this is tertiary. So primary got a greater boiling point. What is the reason? Primary got a greater boiling point. What is the reason? Greater degree of hydrogen bonding, isn't it? Yes. While alkane low value. Alkanes will have low value, right? What about alcohol? Alcohol is pretty high. Close to 400. Here it is 350 only, isn't it? So that comes the nature of physical character. Boiling point, solubility, etc. Now it is about chemical reactions and the basic strength of amines. Chemical reactions and basic strength of amines.